Here's yet another way of deriving those double angle identities in trigonometry. Now, I did a video before where we used the Moivre's theorem to derive these identities. Please excuse my French. But now let's actually use this 2x2 rotation matrix to derive those double angle identities. Now, this video is inspired by a comment that was made in that previous video where someone suggested using matrices to derive these identities. So thank you for that. Now recall that this 2x2 rotation matrix rotates a point in the two-dimensional Cartesian plane through an angle of theta counterclockwise about the origin. So first, if we were to replace theta with 2 theta, then that resulting matrix should represent a rotation of 2 theta counterclockwise about the origin. But rotating through an angle of 2 theta is the same as first rotating through an angle of theta and then another theta. In other words, we can apply this rotation matrix twice, and recall that a rotation is essentially a linear transformation. And if you do a composition of 2 linear transformations, that itself is also a linear transformation. And further recall that a composition of 2 linear transformations can be performed by multiplying the matrices associated with each linear transformation. What all that means is that we have to take the original rotation matrix and multiply it by itself, or essentially square it. Doing so, we get the following product, and now equating that product with the matrix that has 2 theta in it, we can see that if we equate corresponding elements in those 2 matrices, we get our usual double angle identities. Namely that cosine 2 theta is cosine squared theta minus sine squared theta, and sine 2 theta is 2 sine theta times cosine theta. I just think that's also a really slick way of deriving these double angle identities. Now, all of this shouldn't really come as a surprise because recall that rotations in the plane can be performed by multiplying complex numbers together. And the Moivre's theorem is all about multiplications of complex numbers, namely powers of complex numbers. But I think it's nice that there's this connection between the Moivre's theorem and the double angle identities and rotations in the plane. All right, with that, I hope you're doing well. Make sure to hit that follow button for more math content. I would greatly appreciate it. And as always, I'll catch y'all in the next one. Take care.